Hi dear, welcome. Let's discuss the next question together. Here it is our question. The statement of this question is, in figure, ABC is a triangle in which angle ABC is less than 90 degrees and AD perpendicular to BC. Prove that AC square equals to AB square plus BC square minus 2 times of BC into BD. Right? So if you look at this one and previous one, in previous one this one almost same. The only difference is, in the earlier question angle ABC is greater than 90 degrees, here angle ABC is less than 90 degrees. Here it is acute angle triangle, earlier one obtuse angle triangle. So in earlier one, in the final proof we have got here plus, all plus, but here this is minus, like A minus B whole square expansion you can say, right? So shall we start? Right. So given ABC is a triangle in which angle ABC is less than 90 degrees and AD perpendicular to BC produced. Here you can see ABC is a triangle, in this angle ABC is less than 90 degrees and AD perpendicular to BC, right? So this is given information, right? And from this, to prove AC square equals to AB square plus BC square plus 2 times of BC into BD. This is what we need to prove. So for that proof, so since triangle ADB is a triangle, so right angle at D, ABD is a right angle triangle, right angle at D, so we can apply Pythagoras rule, right? So on applying Pythagoras rule here, this is hypotenuse, so AB square equals to BD square plus AD square, right? So AB square equals to AD square plus BD square. So this is equation number 1, right? Now further, in triangle ADC, again this is a right angle triangle, this time this is hypotenuse, so these two are sides, so AC square equals to AD square plus DC square. So AC square equals to AD square plus DC square. Again, so instead of DC, this length is equals to what we can write, this whole length minus this length, right? You can see how you get DC length, BC minus BD, you will get DC. So that is what we have taken here, DC square equals to BC minus BD whole square. So on expanding this by using A minus B whole square expansion, that is A square plus B square minus 2AB. So this we have got AC square equals to AD square plus this one BC square plus BD square minus 2 times of BC into BD, right? So again we can take these two as together, AC square is equals to AD square plus DB square plus BC square minus 2 times of BC into BD. But this value from equation 1 we have got AB square, right? So we can replace this with AB square, so AC square equals to AB square plus BC square minus 2 times of BC into BD. This is equation from 1. So in equation 1 we have proved AD square plus DB square is equals to AB square, right? So from this we can say this one is equals to AB square. So we have got the required proof, right? This is what we need to prove. So hence it is proved. Clear? Shall we discuss once again briefly? Right? Okay. This is the question. In the figure, ABC is a triangle and angle ABC is less than 90 degrees, means acute angle, and AD perpendicular to BC, ABD perpendicular to BC. And to prove AC square equals to AB square plus BC square minus 2 times BC into BD. So for that we have taken given information as it is. This is what we need to prove. So first we have considered this right angle triangle, ABD right angle triangle, right angle at D. So then AB is hypotenuse, so AB square equals to AD square plus BD square by using Pythagoras theorem. So we have got one equation. Now we have considered second right angle triangle, this time ADC right angle triangle. This time AC is hypotenuse, so AC square equals to AD square plus DC square. So DC square, again we know DC is nothing but BC minus BD, right? This minus this is equals to this, right? So we have replaced DC with BC minus BD. So since it is square, so this is also whole square. So by expanding this one by using A minus B whole square algebraic expression, so A square plus B square minus 2AB. So that is BC square plus BD square minus 2 times of BC into BD. Then these two together, AD square plus BD square, AD square plus BD square, these two together we have written here, plus BC square minus 2 times DB into BC, and we know AD square plus DB square is what? from equation 1, that is AB square. So AC square equals to AB square plus BC square minus 2 times of BD into BC. Hence it is proved. Clear? This is it.